it's Miss Robinson, your third grade math teacher for the year. And we have been going over fractions the past few weeks, but we're going to move on to geometry. And what geometry is the study of different figures and shapes and stuff like that. So that's stuff we've gone over in second and first grade as well, but we're going to really expand on it. Like everything else we do in third grade, we're going to go deeper into it. So let's look at our objective. I can identify the attributes of different two-dimensional figures, specifically quadrilaterals. So let's just kind of take this apart for a second because there's a lot of words, a lot of vocabulary in here we may or may not be familiar with. Let's start with this word attributes. Attributes is another word for characteristics or qualities or things that we can observe about a figure or anything really, an object, just we use our senses, and with geometry, we'll be using our eyes, right, our tools to measure. Sometimes two-dimensional figures, we know those are plane shapes, right? Shapes that are flat, they don't have any a third dimension to lift them up, right? We will talk about three-dimensional figures more next week, but this week we're talking about plane figures or two-dimensional figures. Specifically quadrilaterals. So we will go over like just the basics of different figures or shapes. But quadrilaterals is really where we're going to kind of hone in on and talk about what a quadrilateral is and the different types there. There's lots of shapes that qualify as quadrilateral. And that's something we'll talk about today. All right, let's get started. Okay, like I mentioned before, we are going to be going over two-dimensional figures and quadrilaterals, which are two-dimensional figures. We're just going to go more in depth with them. But first, we're just going to look at these plane shapes, which means two-dimensional figures, right? We're going to look at them, and we're going to kind of, some of these are real basic. We've been going over them for years and years, but we're just going to kind of go over like what makes them different from each other, and that all comes down to how many sides they have and how many vertices, or if they have a vertex. And a vertice or a vertex is when two or more lines meet, when we have a point, something that causes there to be a point, right? We can see on this square where these two lines meet, that's a vertice, or that's a vertex, and more than one would be called vertices. So let's look at this circle. We're looking for sides means like straight lines, not curved lines. So we have one curved line. We have one curved line, but 0 vertices. And really 0 straight lines, but we can kind of see that if there's one curved line. With a square, we have 1, 2, 3, 4 sides or 4 lines. And 1, 2, 3, 4 vertices. With the triangle, these are all these first half of the shapes are the ones we've been going over forever, but we still need to review them. A triangle, we have 1, 2, 3 sides, and 1, 2, 3 vertices. With an oval, we just have one curved line, right? One circular line, one curved line, and 0 vertices. With our rectangle, we have 1, 2, 3, 4 sides or straight lines, and 1, 2, 3, 4 vertices. Notice I am drawing lines on my sides or my straight lines because then I can keep track of my counting. And this isn't, obviously, I don't really need to do it for squares and triangles and rectangles, but it's going to help me in the long run whenever I'm dealing with these bigger ones, these hexagons, heptagons, octagons. And then I'm doing little points for my vertices, same reason. It's an easy thing for us to draw. Some people like to circle them. I can show you that with the next one we do, the rhombus. I just like to do dots, but if your dots are really little, then circle it. Okay, a rhombus. This looks like what we might have called in the lower grades a diamond. We do not say the word diamond in 3rd grade. We do not say that word. We call it a rhombus. We are smart 3rd graders. We're going to use smart vocabulary, okay? This is a rhombus. 1, 2, 3, 4 sides. And I'll show you, some people like to do this. 1, you see how it's just kind of circling it? I can zoom in a little so you guys can see that. See how it's circling it? 1, 2, 3, 4. I prefer drawing the dots because to me it's easier when they're smaller. But I'll do a few more with the circling the vertices. We have 4 vertices. Notice a pattern that we're starting to see. It seems that however many sides or straight lines we have, we end up having that many vertices for these closed figures. Okay, let's count our parallelogram. 1, 2, 3, 4. We have 4 sides or straight lines, and 1, 2, 3, 4 vertices. All right, a trapezoid. 1, 2, 3, 4. 4 sides, straight lines, and 1, 2, 3, 4 vertices. I'm going to go back to just drawing the points because these figures are getting, the vertices are getting smaller. Now a pentagon. 1, 2, 3, 4, 5. So we have 5 sides or straight lines. And 1, 2, 3, 4, 5 vertices. A hexagon. 1, 2, 3, 4, 5, 6 sides. And 1, 2, 3, 4, 5, 6 vertices. A heptagon. We will not see a heptagon very often. I'll never require you guys to draw one, even if you guys were in my class, because it's difficult. It's difficult to even do an octagon or a hexagon, to be honest, sometimes. But we'll still learn about it. So a heptagon has 1, 2, 3, 4, 5, 6, 7 sides. And 1, 2, 3, 4, 5, 6, 7 vertices. And our last one out of this chart, an octagon. 1, 2, 3, 4, 5, 6, 7, 8 sides. And let's count how many vertices. I'm sure we can all figure it out by now by seeing the pattern, but let's still count to be safe. 1, 2, 3, 4, 5, 6, 7, 8 vertices. Now I'm going to zoom out so we can see the whole thing we just did. So the only ones that didn't have any straight lines or sides was the circle and the oval. They had a curved line. They didn't have any vertices and they didn't have any straight lines, but they had a curved line. The rest we can see however many sides or straight lines we had was the same amount of vertices for all of these figures because they're closed, right? They're closed figures. All right, let's go over some vocabulary before we get too far into this. So some vocabulary I would like us to go over is, so one word that we saw in our objective today is the word attribute. We saw that word attribute. An attribute just means it's a characteristic of an object. It's another word for saying a characteristic, right? We use that word in reading, right? We say characteristics of different parts of the story and stuff like that. It's the same thing. So a characteristic of a figure or an object or really anything. There's not really a picture we can draw with that to really show that. That would be more like something we'd have to display. Another word that we're going to see as we move into our quadrilaterals is this word congruent. Congruent is a really important word. I use it a ton in my classroom because we need to really understand in geometry we have a lot of vocabulary. We have a lot of words that we use and we have to know what they mean, which is kind of confusing because we're doing math, right? But we need to know what these math words mean. So the more we practice them, the more it is the same. Or I'm sorry, not the same. The more we know it. What is the same? That's what the definition for congruent is. It's equal or the same size and shape. So it could be equal figures. It could be equal size lines. It could be all kinds of things. This is just another word for equal or same size or shape, right? We could have used these with fractions when we were doing equivalent fractions. The equivalent fractions were congruent to each other. So an example I could draw for this would be, let's draw a rectangle. We have two different sets of congruent lines, right? This line is the same size as this line. That just means they're equal. This line is the same size as this line. All right, and another word that we really need to go over in before we get too far into this is this word polygon. And all a polygon is a shape, a two-dimensional shape with straight lines. Two-dimensional, I'm just writing 2D because I don't need to, it's an abbreviation for it. Figure with straight lines. So it's basically like any shape that's not a circle or doesn't have a curved line in it. So some examples would be a triangle, rectangle or square, and then we could just do some silly shape looking thing. And the last word we're going to go over is something that's going to lead into what we're doing next, which is quadrilateral. Quadrilateral. And a quadrilateral, I want us to look at this word quad. Quad means four. So a quadrilateral is any polygon or figure that has four straight lines and four vertices. So some examples might be anything with, well, it's really anything that has four straight lines and four vertices. We could do a rectangle. We could do a trapezoid. We could do some odd shaped. So I'm just going to zoom out so you can see the vocabulary we went over. I was going to add vertex in here, but we went over what a vertex was, and so I don't want to waste our time just adding stuff we've already gone over. Especially because we only get 30 minutes to go over these lessons. All right, so now we're going to go over specific kinds of quadrilaterals. So this activity we're going to do is an activity that kind of just talks about the different characteristics, or not characteristics, not even attributes really, the different ways we can call different types of quadrilaterals. So first, it says a quadrilateral is, the first one I'm going to draw is just going to be a polygon. It's going to be a non-specific. That means it doesn't really fall under any other category besides being a quadrilateral. I love these dotted papers because it really helps me show my students where things are congruent or the same and where things just really aren't. And it also helps me draw straight lines because I can use those dots to help. See, none of these lines are parallel, which we'll go over what parallel means in a little bit. None of these lines are, actually we'll talk about parallel now. Parallel means that they will never ever touch each other. So they go like this forever, or they go like this forever. Like look at these lines. These lines are parallel to each other. One way of thinking about it is thinking of like a train track. A train track is going to go on and on and on forever, and those two lines that lead the train are never going to touch each other. So that means parallel. So a quadrilateral is a polygon. Okay, so like I said, a quadrilateral is a polygon because all a polygon is a shape or a closed figure with straight lines. And there we go. We have a 1, 2, 3, 4, and 1, 2, 3, 4 vertices and sides, and they're all straight lines, so it's a polygon, and it's a quadrilateral. Now we're going to draw another type of quadrilateral. This is called a trapezoid, and we're going to say is a trapezoid is also a polygon. A trapezoid is also a quadrilateral. Next, we're going to draw another figure. This figure is going to look like this. This is called a parallelogram, and a parallelogram has two sets of parallel lines. We see these two lines are parallel, they will never touch, and these two, even though they're going this way, it doesn't matter what way they are, is a quadrilateral and a parallelogram. So a parallelogram, I always get my R's and L's mixed up in this, so I'm going to make sure I write this correctly. Parallelogram is, so parallelogram is also a polygon because it's a closed figure with straight lines. It's also a quadrilateral because we have 4 sides and 4 vertices. Now this is where it gets a little bit more exciting. We know, we've learned that what a quadrilateral is, a polygon, a trapezoid is a type of quadrilateral, and same with a parallelogram. Now what we're going to deal with is some of these things are going to qualify for more than just being a quadrilateral and a polygon. So our next one is very familiar with most of us. This is a rectangle. So we have a rectangle. Notice these rectangles have what we call a right angle. An angle is another word for a vertex of a plane shape or a two-dimensional figure where the two lines meet, and you can measure how big or small that corner is. It's called an angle. And a right angle means that it makes a square or a rectangle. It's at a certain degree. It's called 90 degrees, but we don't really learn about that in 3rd grade so much. But what we do need to know is that these lines make a perfect L, right? A perfect line. And this is a rectangle. Is, we know it's definitely a polygon. We know it's definitely a quadrilateral. But it's also a parallelogram because it has two sets of parallel lines. It's even more fun, guys. Our next one is a rhombus. A rhombus. You guys are going to be able to see this, so let's see. No, we're going to need darker color. So this is a rhombus. And a rhombus is any quadrilateral that has 4 equal sides. The length of all 4 sides is equal. So that a rhombus is, so it's a polygon. It's a quadrilateral. It's also a parallelogram because look, these two sets of lines are parallel. They have to be parallel in order for them to be the same size. And connected, right? If they're all connected together. So a rhombus qualifies under all those. It doesn't qualify for a rectangle because look, these angles are different sizes. Another way to tell the difference between a rhombus and a rectangle, and how to tell it's a rectangle specifically, all 4 corners, all 4 angles, all 4 vertices, whatever you want to call them, are the same size. Since we don't really deal with like sizes of angles, and we're like, I don't know what 90-degree angle is, right? I'm in 3rd grade, I haven't done that before. Well, all 4 of them are the same size, so then it's a rectangle, or what we're going to talk about last out of these, which is a square. Now a square also has these same size corners in all of them. A square is, and a lot of the stuff, you've been talking about these shapes since you were little, but you just haven't really gone over the specifics that make them different from other ones, and that they're quadrilaterals. A square is a polygon. A square is a quadrilateral. A square is a parallelogram. Because look, all 4 sides, a square has to have 4 equal sides, and all the sides are, well, there's 2 sets of parallel lines. Excuse me. A square is a rectangle because a rectangle doesn't say that 2 of the sides have to be equal and 2 of the sides don't have to. So technically a rectangle could have equal sides, but a square can't have unequal sides. So a square can be a rectangle can't be a square. I'm sorry. I said that wrong. A square can be a rectangle sometimes. A square is always a rectangle, but a rectangle isn't always a square unless all the sides are equal. And a square is also a rhombus because all 4 sides have to be equal. So let's kind of go over the different figures we went through today. We started with just a very generic, unspecific quadrilateral. Then we went specifically into the different quadrilaterals with our trapezoid, 1 set of parallel lines, parallelogram, 2 sets of parallel lines, rectangle also has 2 sets of parallel lines, but all 4 corners are the same size, or all 4 angles, or all 4 vertices. A rhombus, which is like a parallelogram, but all the sides are equal. A square, which can be any of them except for a trapezoid. It has 4 equal sized sides, is the only difference. All 4 corners are the same size, 2 sets of parallel lines. and it is also a quadrilateral. All right, guys, so we talked about different two-dimensional figures or plane shapes, right? We talked about circles, hexagons, triangles, all kinds of stuff we've been going over for many years, right? We just kind of specified the differences by looking at how many sides they have, if they're straight or curved, and how many vertices or angles they have. Then we went over different types of quadrilaterals and what they have different categories, right? Like a square and a rectangle and a rhombus are all technically a parallelogram, and they're all technically a quadrilateral because they have four sides and four vertices or angles. But like a trapezoid is kind of its own special one where it only has one set of parallel lines. We talked about a bunch of that, and I want you guys to be practicing that over this week so that next week when we move to three-dimensional figures, you're going to be so ready and you're going to know all your quadrilaterals by heart, okay? I'll see you guys next week. Can't wait. Bye.